Hello and welcome.
Introduction. In this video, I'll show you how to interface an external LED and an external push button switch to the Tiva C-Series LaunchPad board. So let's begin by taking a look at the Tiva TM4C 123GH 6PM microcontroller high-level block diagram. Now, I've taken this block diagram from the microcontroller datasheet, page 48. So what I'm interested is in the GPIO module. So let's zoom in onto the GPIO module. So the GPIO module consists of 6 physical GPIO blocks, and they are port A, port B, port C, port D, port E, and port F. Now, it supports up to 43 programmable input-output pins. However, only 35 GPIO pins are available on the Tiva C-Series LaunchPad evaluation board. So let's take a look at the schematics of the Tiva LaunchPad board. Now, I've taken this schematic from the Tiva C-Series user guide. You can find it on page 19. So we have here the red LED, blue LED, green LED, the user switch 1, user switch 2. You notice all these are connected to port F. However, in this video, we're going to use port E, which is this port here, port E, to interface an external LED and an external push button switch. So we'll be using port E. Schematics. Now here are the schematics for the external push button switch, and here's the schematic for the external LED interface. Let's take a look at the push button switch schematic first. So we have a resistor R connected, one end connected to VDD. The other end of the resistor is connected to PE5 of the microcontroller, that is port E bit 5, and the other end of the resistor is also connected to one end of the push button switch, and the other end of the push button switch is connected to ground. So let's look at the value of R. So for most application, R can be 10K to 50K ohm for a pull-up or a pull-down resistor. 10K is often used because it's a good balance between noise immunity and power consumption. Now, with a 10K ohm resistor and a 3.3 volt supply, the current is, using this equation, I equals to 3.3 volts divided by 10K ohms. That will give you or give us 0.33 milliamps. Now, from the data sheet, I've extracted this table 24-1, absolute maximum ratings. And if you look at here, the maximum current or output pin. So let's zoom in a bit here. You will see that 0.33 milliamp is still within the range, the maximum range of 25 milliamps. Now, another way to look at this is to consider using this equation. I equals VDD minus VIH min volt divided by 10k ohm. Now, where does this come from? This VIH, I've taken it from table 24-6 of the data sheet. That is the GPIO high level input voltage. And we can see the max is 5.5, but if we take a look at the minimum, that will be 0.65 multiply VDD. So if you substitute this into here for min, then we will get 3.3 minus bracket 0.65 multiply 3.3 volts divided by 10k ohm. That will give us 0.115 milliamp. Now this is still within the 25 milliamp. Don't forget this is the maximum current per output pin that we've seen earlier. So 0.115 milliamp is still within the 25 milliamp. Now that we're done with the push button switch, let's consider the LED interface schematics. Now this circuit here, this is a common LED interface schematic that I use quite often, but with the TM 4C123GH6PM microcontroller, the high level output is 2.4 volts. So this is the high level output voltage, which is 2.4 volts. So a circuit like this that will work with the ATmega AT89S52 or the ATmega 328, it would not work for the TM4C123GH6PM microcontroller. So what is needed is a schematic like this, which consists of a transistor, which is a BC547. The collector is connected to a resistor, and the resistor is connected to LED, which is connected to VDD. The base is connected to port E bit 1, PE1 of the TM4C123GH6PM microcontroller. Now, let's look at how we could calculate the value RB and RC. So first thing is we assume IC, the current flowing through the collector, is 10 milliamp. 10 milliamp is adequate to turn the LED on. So we settled down with 10 milliamp for IC. Now, what about IB, the base current? Now, IB, we can use this equation. IB set approximately IC divided by 10. Now, this is a rule of thumb. All right. So we substitute IC 10 milliamp divided by 10. That will give us a 1 milliamp. So IC would be 10 milliamp and IB would be 1 milliamp. So for RC, we use this equation, VDD divided by IC. So that will be 3.3 divided by 10 times 10 to the minus 3. That will give us 330 ohm, 330 ohm. Now for RB, that would be VDD divided by IB, the base current. That would be 2.4 divided by 1 times 10 to the minus 3 equals to 2K4 or 2.4K ohm resistance. So these are the resistance value that we need for this schematic. Wiring diagram. So here's the wiring diagram following the schematics that we discussed earlier. So this is the push button switch with the 10k ohm resistor. This point is connected to PE5 on the Tiva C series LaunchPad board. And here is the transistor, and this is the 2.4k ohm resistor connected to the base. And from the resistor is connected to PE1 on the Tiva series board. And here is a yellow LED, which I'm using. And this is the 330 ohm resistor.
The program.
Okay, so the program that I'm going to use or present in this video is identical to the previous video, that is video 87, push button switch and LED, ARM Cortex M4 assembly language, except for the registers that I'll be using this program. It will be different from this program here. This program 87, or the video 87, uses port F, whereas in this particular video, I'll be using port E. All right, so if you want more details regarding the entire program, or I would recommend that you watch video 85, controlling RGB LED using ARM Cortex M4 assembly language. So, but in this video, what I'm going to do is I'm going to briefly go through the program. But like I said, if you want more details, please refer to these videos. I've included the links to this video in the description. So I'll start off with the definition of the registers used here. Like I mentioned earlier, we're using port E for this program. So just to mention that port E, the APB, or the Advanced Peripheral Bus base address for port E, the base address is 4002400 hexa. So if you want to work out the addresses of these registers, you need to refer to the datasheet for the offset and then add the offset to the base address to obtain the addresses of these what we call registers. Now here I've also included the mask for bit 5, that I call that port E bit 5 mask, and the mask is 20 hexa. Now here I define the section of area code where the code is stored and all its attributes. Here the export here is exporting this symbol __ main, and then the word entry. This denotes or signify the beginning or the entry point of the program. Let me just go back. This export, for those who are new to this export is a directive. The purpose is to make this symbol visible to the linker and other modules that might want to use the code listed here. Main program. So this is the beginning of the main program. So it's __ main, PROC. That's the directive for procedure. So the beginning of the procedure, all the subroutine is a branch to a subroutine called set port E. more on this coming soon. Now, these two instructions here, this will basically load or copy this value, which was defined at the beginning of the program, and then get this value, load it or copy it into register R1. And this instruction here basically will copy the contents of the address which is pointed to by R1. Now R1 is pointing to this address, so it will go to that address, get the contents and copy that or load it into R0. It's not copying the contents of R1, but rather it will copy the contents of the address pointed to by R1. These two instructions basically, it will check the status of the switch connected to port E bit 5. This next three instruction basically, it will turn the LED off. That's the purpose of these three instructions. Again, the details of how this operates, please refer to the earlier videos that I mentioned. And here, B loop here means branch back to this part of the main program. So that's branch to this point here. And END is basically end of procedure. So this signifies the end of this procedure or subroutine.
Subroutines.
Now, the first subroutine is the initialization subroutine. So this is the start of the set port E subroutine, and it begins with this directive PROC, that is the directive for procedure, or I call it subroutine, and ENDP here means end of a procedure. So these two directives goes hand in hand. So the first three instructions here basically is to enable the clock for port E. All right, so that's the purpose of these three instructions. Next come four NOP instruction. NOP stands for no operation. The purpose of these NOP's instruction is to allow time for the clock to stabilize. So basically, this is a very short delay. The next three instructions here deals with the alternative function select register, or AFSEL register. Basically, here we configure all pins of port E for GPIO operations. Next comes the digital enable register. Basically, these three instructions is to configure port E for digital I/O function or digital input-output function. And the next three instruction deals with the direction register. Basically, these three instructions here configures port E or set up port E for output mode, except for bit 5. So if it's 1, it is output. 0, which is the only bit here, that's bit 5. That is for configure it as input mode. Finally, we have this BXLR, that is to return to the main program, the calling program. As mentioned earlier, END here means end of procedure.
Turn on LED subroutine. So this is the turn on LED subroutine, and this is the PROC directive, or the procedure directive, which is indicating the start of the procedure or the subroutine. And here is the ENDP, the end of the procedure. Right. Now, these three instructions here, basically the overall purpose is to turn on the LED. So when the push button switch is on, this subroutine will be executed and it will turn on the LED. And BXLR, that is to return back to the main program, the calling program. And we mentioned ENDP earlier, and END, or end here, this indicates, this is the directive that indicates the end of the entire assembly program. Demonstration. So for this demonstration, you will need the Tiva C series LaunchPad board connected to the external LED and external push button switch circuit, which you should have built on a mini breadboard or breadboard. So, and you need to connect your Tiva C series to the to your laptop or desktop. Okay, so before I get into demonstrating the code, I just want to show you my setup here. So I have my Tiva C series LaunchPad board here, and it's connected to my laptop. So, and then here is the circuit that I built on a mini breadboard. So here is my LED interface, and here is my push button switch. All these are connected to the Tiva C series LaunchPad board using these jumper wires. Okay, so let's go have a look at the code. So here is the code which I've uploaded to the Kyle IDE. So let me just briefly go through this with you again, very briefly. So here I define my registers with all the appropriate addresses. Here's my mask, and here's the part where I define the code and all its attributes. Here's the export directive, and then here's the entry point, and from this point onwards is the main program or the main procedure, right? Proc, and then end of proc. So this is the main program. I won't go into the details because we have discussed this earlier. And here is the this is the starting point of set port F procedure or subroutine, and it ends here. Again, I won't bore you with the explanation because we've done that earlier. And then the second subroutine, the turn on LED subroutine, is here. All right, proc, and then end proc, and end here signifies the end of the entire assembly program. So let me just, for demonstration purposes, go to project and then build target. And watch this part, 0 errors, 0 warnings. Then now it's ready for downloading to the board. Okay, so so I'll download the code first. So download, and it says programming done, verify OK. So let me just bring my board back up here. So I've downloaded the code to the Tiva C series LaunchPad board. So let me just press reset. All right, and then if I go over to the circuit, and then let me just hang on to the breadboard. If I press now using my thumb, the push button switch here, you should see, or we should see, the yellow LED turn on. So let me press it. Yes, let go. Press the push button again. It's on, LED is on. And let's do it one more time. And the LED comes on. That's it for this particular demonstration. Okay, that's it for this video. Thank you for watching, and I'll see you in the next video. Bye.